except it has to do twice as much computation work as for the Euler. So it's a little trade-off. All right, so now we have gone through the list of properties we want the scheme to satisfy, and we have seen one example of getting a scheme that satisfies all the properties we want. So what else can we do here? Okay, one thing is to derive more schemes similar to this, right? The reason this is called the RK2 scheme is because there is actually a family of schemes. This is called the RK2 scheme. 2 stands for, it's actually a scheme that is has 2 stages. This is called stage 1. This is stage 2, right? Basically, you have to go through both stages to complete one step, and every stage has a slightly different formula. There are RK 3 scheme, RK 4 scheme that has 3 or 4 stages, and there are even 5-stage up to 7-stage, 9-stage schemes people have painstakingly derived. I mean, some of the more complex schemes might be a PhD thesis, right, to kind of figure out. But we have figured out all of these schemes, and a lot of them has been integrated into software such as MATLAB. So in MATLAB, if you use some of the standard ODE integration schemes, you probably used something like ODE45, right? So ODE45, what it actually does is it internally runs a 4-stage RK scheme and a 5-stage RK scheme. Okay, that's where the 4 and 5 come from. And it actually compares the result of these 2 different schemes. If the result is very different, it means your time step is too large, right? And automatically cuts the time step. And you have a criterion to satisfy to basically, the 2 schemes have to agree to enough precision for you to accept the solution and go forward. That's what MATLAB does, right? And in the future, if you work on more complicated software and to have to add like user-defined functions into, let's say, a fluid flow calculation or something, you might be affecting the stability properties of whatever scheme that is used. And if you know the internal workings of these schemes, you should be at a much better position of making wise choices in what to do. All right. Okay. Any questions before we discuss one last topic? The last topic I want to discuss is something quite common in the kind of stability regions we saw, is that none of these schemes we have seen so far has stability regions that extends to negative infinity, right? I mean, they stop over here. Once your lambda is less than -2, or in general, -2 divided by delta t, you are unstable, even though the analytical ODE is stable. Is that a concern? Or